surely that graph's wrong, right? I mean, Chris Monckton says it's wrong. So I decided to write to the NSIDC, and I wrote to Dr. Mark Cerisi. And here's the question I wrote to him. I mean, I'm not trying to fish for an answer that makes me happy. I'm trying to be fair. And I'll just read this. Pardon this question. I'm a professor in thermal sciences at the University of St. Thomas. I give lectures on climate change and solution strategies. Contacting you because recently a climate change skeptic, Christopher Monckton, has been claiming there's no cause for concern regarding Arctic sea ice and that all recent losses are temporary and solely caused by wind ocean fluctuations. My understanding is different. There's a systematic decrease in Arctic extent. While there are annual variations related to Arctic oscillations, the time-smooth trend is largely Arctic warming. Can you clarify who's correct? So I'm trying to lay out both cases very clearly, and let's see what he says. Here's his answer. Monckton is wrong. So you see, people at major research centers that study this stuff don't agree with Monckton's interpretation. Now, getting back to the data which Chris Monckton's put forward, that was from the IARC again. I did get a reply from Larry Heinzman, and he says, you know, I'd agree with you on this argument. I think you're right. Arctic sea ice is decreasing. But who is Larry Heinzman? Well, it just turns out he's the director of IARC, which is the organization Chris Monckton referenced in his own presentation. So again, Chris Monckton's using science, and his interpretations of the science are not in agreement with what the actual originators of the data suggest. Staying with this sea ice theme on slide 57, Chris Monckton says Greenland ice sheet is just fine. And he takes a quote from a paper by Johannesson and others from 2005. So is Greenland fine? So again, that was on slide 57, just over an hour into the presentation. And the quote from Chris Monckton was, here's a paper by Johannesson et al., a very diligent Danish researcher using laser altimetry, and what he found was that from 1992 to 2003, the average thickness of the vast thickness of Greenland's ice sheet increased by 2 inches a year. And I'd say, wow, that would be interesting if it were true. And more importantly, what does this mean in terms of climate change? Does this mean global warming is not happening? Well, on February 3rd, 2010, I contacted Professor Johansson. He referred me to the following paper. It's a very recent 2009 paper, and here you can see they indicate a loss of 273 gigatons of ice. So you can see that Greenland is not gaining ice. It is rather losing ice to the tune of almost 300 gigatons per year. Now, Dr. Johansson also provided me a link. Here's the link. And that was a very long document, and I just want to show you a couple quotes from that document. These aren't all-inclusive, they're representative. Page 24, you'll find the quote, the trend in surface mass balance appear to be a response to global climate change. And on page 36, again, they're talking about particular vulnerability of global climate change and the warming since 1979, and then again on 39. So again, the author of the paper, which Monckton referenced, does not agree with the Monckton interpretation. And just so you can see the actual citation from Dr. Johannesson, here it is. Here's the email reply to me. Here's the link so that people can go and investigate it themselves. And then at the top as an attachment is the 2009 paper, which I referenced. What do other people say about Greenland and other ice loss? Well, here are 4 papers, and I've given the full citations, and for 3 of them I've given the links, and so you can go and read these yourself and see if Chris Monckton's interpretation is accurate. What about Himalayan glaciers? Himalayan glaciers are in the news recently because of the misprint in the IPCC 2007 report. Here's a paper talking about Himalayan glacier ice loss, and this was published in 2007. Here's another one, and I've got the link here so that you can go and read it yourself. But the quotation right from that abstract is related to the emissions of greenhouse gases and changes in the global climate by the end of the current century. And another paper, and again, I've got a link, and I've got a quotation right from the paper with a full citation so people can access it themselves. And again, Himalayan glaciers, 2007, and here's a quotation taken right from that paper. Here's a screenshot of that paper. And then here is the highlighted text, screenshot of the paper with the text highlighted. All right, on slide 70, Chris Monckton talks about CO2 being a trace gas, and he's right. CO2 is a trace gas, and really essentially he's saying is it's not present in great quantities in the atmosphere. In fact, the atmosphere is made up largely of nitrogen, N2, and oxygen, O2. The greenhouse gases like carbon dioxide, water vapor, methane, nitrous oxide, etc., they're present in very small amounts. Now that doesn't mean that their impact is small. It just means that if you look at them as a percentage of volume, they're present in a small amount. Now what he does is a little bit of a game with numbers. He says, 1750 it was only 0.03% by volume, 2009 is 0.04%, so the change is 0.01%. But it's not a really good way of showing the change. He's measuring the increase of carbon dioxide as a change in volume percentage. A better way to measure it is by the percentage increase in carbon dioxide. So I'd ask, how much has carbon dioxide increased since pre-industrial times? So again, the inference Chris Monckton's giving is that the increase in carbon dioxide is very small. And he's using this measure of percentage volume to reinforce that conclusion. And remember, carbon dioxide is a trace gas. It's present in very small amounts in the atmosphere. That doesn't mean that its impact is very small. But what people think about when they look at Chris Monckton's slide is that the actual increase of CO2 is not very great. And that's not a correct interpretation. A better way to interpret the carbon dioxide increase is to look at the percentage increase of carbon dioxide. Carbon dioxide is at about 390 parts per million. Pre-industrial is 280. So there's been almost a 40% increase in CO2, and that increase is due to human effects. So the better way to look at carbon dioxide is by looking at its percentage increase, not at looking at the change in volumetric percentages. It just gives the incorrect interpretation that increases of carbon dioxide are negligible. Now, Chris Monckton gets onto another topic of the cooling of oceans, and he shows this graph, and this is slide 72. And notice this has no attribution. So he does mention Argo SST on the left, and Argo are Argo floats. SST stands for sea surface temperature, but he doesn't say who's providing this information. A proper citation, in my mind, would be giving the journal publication with the full citation so that readers can go and investigate themselves. Well, let's see what he continues doing. This is actually a different slide. This is slide 40, and you'll notice here he mentions Argo 2009. And again, Argo is a measurement technique related to Argo floats. There is no author named Argo. So if you just look at the way he's citing this, it seems like there's an author named Argo who published a paper in 2009. That's not correct. So, and he continues, and sea level and ocean heat content are closely related. Now, what he says in slide 73 is sea level has not risen for 4 years. And the inference he's giving is, you know what? Either global warming stopped or it wasn't a problem. Well, the problem is he takes this graph from the University of Colorado, and you can see the trend line. That's the black line. And the black line showing a continual increase in sea level. And just to be sure, let's actually go to the University of Colorado and see what they say about it. So, again, he cites the University of Colorado. Let's ask the researcher that made that figure. It's Tad Pfeffer, and here's his reply. There's indeed a leveling off of sea level over the past 1.5 years, but his conclusion, Monckton's conclusion that sea level rises over on this basis strikes me a bit like assuming that at dusk the sun will never rise again. So, and then he goes on to say what we're seeing is not enough to explain what's happening. Prediction tends to be a rash business, and he talks about the rashness of Monckton's claims. So again, the author of the research that Monckton cited does not agree with the Monckton interpretation. And on the next slide, this kind of trend continues. Here you see a publication in 2009 by Douglas and Knox, and they used data from Katia Dominguez. And that paper reportedly shows no ocean heat buildup for 50 years. So let's go to Dominguez and let's see what the data really says. So again, it would be incredible if it were true that there was no ocean heating in the last 50 years. But here's the paper. And here are graphs from the paper. Notice that these graphs measure energy in joules, and that's the appropriate measure of thermal energy. A watt per meter squared, which is what Chris Monckton showed, is a heat flux. So the unit in the original document was in joules. And here's the email from Katia Dominguez. And clearly she says, you are correct. And we found that the upper 700 meters of the ocean has warmed from 1950 to 2003.